Okay, hi guys. So in this lecture, we'll be seeing types of chemical equations. So let's get started. So we have to see types of chemical equations. Okay. So first, let us see homogeneous chemical equation. Homogeneous chemical equation. Okay. So in a homogeneous chemical equation, all reactants and products are present in same phase. All reactants and products are present in same phase. Present in and B, we have heterogeneous chemical equations. In which reactants and products are present in more than one phase. Reactants and products are present in more than one phase. Okay. So next, let us deep down into homogeneous chemical equations or homogeneous chemical reactions. Okay, so homogeneous ones. So let's see some examples on the same. We have N2G plus 3 moles of H2G reacting. This is a chemical reversible reaction. So 2 arrows will be present and 2 moles of NH3G are getting formed. So Kp in this case would be partial pressure of NH3 square divided by partial pressure of N2 multiplied with partial pressure of H2 cube, and Kc would be concentration of NH3G whole square divided by concentration of N2G multiplied with concentration of H2G whole cube. Okay. So next, let's see some more example. So we have HBrG getting formed into H2G plus Br2. Okay, so Kp again for this reaction would be H2. Kp would be partial pressure of H2 into partial pressure of Br2 divided by partial pressure of HBr whole square, and Kc would be nothing but concentration of H2 into concentration of Br2 divided by concentration of HBr whole squared. Okay. Next, let's say another example wherein we have carbon monoxide in gaseous form reacting with half moles of oxygen again in gaseous form, forming CO2 again in gaseous form. Okay, so the Kp for this reaction would be partial pressure of CO2 divided by partial pressure of carbon monoxide into partial pressure of oxygen to the power half, and Kc in this case would be again concentration of CO2G divided by concentration of carbon monoxide and concentration of O2G raised to the power 1 by 2. Let's see another example wherein we have NH3 gas in gaseous form. Let's say we have NH3 minus, not minus, let's say we have NH3G only. Then we have H2L forming NH4 plus aqueous and OH minus aqueous. So this is not a homogeneous reaction. This is a example of heterogeneous reaction. So in this case, this is a solvent which is present in excess quantities. Okay. So Kp won't be defined for this case, and Kc, as none of there is no gaseous phase in the product side, hence Kp is not defined, and Kc would be concentration of NH4 plus concentration of OH minus divided by concentration of NH3G. We won't be taking into consideration the solvent as it is present in excess quantities. Okay. Now let's actually see some of the points here, that the concentration of water is not written as concentration of water doesn't change appreciably. So concentration of water is not written as there is no appreciable change in its concentration. Okay, and second point is that in the above reaction H2OL is present as solvent. Its concentration during the process of reaction remains constant, so we do not consider it in the equilibrium constant expression, which was Kc in our case. So just writing that in the above reaction H2OL is present as solvent, and its concentration during progress of reaction does not change considerably. Hence we are not writing, we do not include that in equilibrium constant, which was Kc in our case. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing more reactions and more involvement of Kc and Kp in those equilibrium reactions. Till then, good luck and goodbye.